For decades, one material has defined high-performance labs. Epoxy resin, the industry's default choice for durability. But the standard choice might be more fragile than you think. What if the harder surface isn't the toughest? We're also looking at a material that can outlast its main competitor by more than a decade. And it can shrink your project timeline from 2 months down to just 2 weeks. We're putting epoxy head-to-head with phenolic resin on performance, cost, and safety to find the best choice for your lab. First, what are they? Epoxy is a poured monolithic mixture of resin and fillers. Phenolic is a composite of craft paper and resin pressed under extreme pressure. Think of hundreds of resin-soaked paper layers fused into one solid, dense panel. This layered construction is key to its unique properties. In the lab, heat is a constant, so how do they compare? This is epoxy's clearest victory. Epoxy resin withstands extreme temperatures, even direct flame, making it the clear choice for high-heat fume hoods. Phenolic offers good heat resistance up to about 350 degrees Fahrenheit, but it is not flame retardant and can be damaged by prolonged high heat. So for raw heat and flame resistance, the point goes to epoxy. But that is only one part of the story. Now for the paradox, impact resistance. We know epoxy is a harder material, so why is it more likely to chip and crack? Its monolithic structure is the cause. Like glass, extreme hardness can mean brittleness. Impact energy has no place to go, causing a chip or a crack at an edge. Phenolic's layered makeup works like a shock absorber. Impact force is distributed and dampened through the resin-fused paper layers. It is the difference between a ceramic plate and a composite hockey stick. One is harder, but the other is far more resilient to impact. So, while epoxy is harder, phenolic is tougher, and when phenolic gets minor scratches, they can often be sanded out, a fix impossible for a chipped epoxy edge. Phenolic wins on toughness. What about chemical spills? Here, the correct answer is not better, but different. Let's shift to project realities. First, budget. Phenolic is often more expensive up front, but installation costs are frequently lower. Next, installation. Phenolic is much lighter than epoxy, which means lower shipping costs and easier handling on site. Need on-site modifications? Phenolic can be cut with standard tools. Epoxy adjustments are difficult and costly. And the timeline. Standard phenolic can arrive in 5-10 days. Epoxy can take 8 weeks, a major project bottleneck. So while it may cost more initially, phenolic is lighter, easier to install, and months faster to get. On logistics, phenolic has a clear advantage. But a lab must be sterile. Epoxy's joint-free surface is a known advantage. Yet, phenolic is also highly moisture-resistant and inherently antibacterial. While epoxy is great against strong acids, phenolic is superior with other solvents. It scores a 0 on the CIFA acetone test and tolerates a pH range from 0 to 14. Today, sustainability is a factor. Phenolic is often made with recycled paper. Epoxy, full of silica, is difficult to recycle. The smartest labs don't pick one. They use a hybrid approach, epoxy for high-heat fume hoods and phenolic for general workstations. With all these trade-offs, how do you find the best long-term investment? We have to connect the upfront cost to the product's total lifespan. Let's connect the dots. While phenolic often has a higher initial price, it has a much longer service life, over 25 years versus 15 to 20 for epoxy. When you combine that initial price with a 30 to 50% longer lifespan and lower installation costs, the total cost of ownership often favors phenolic. There is one final factor, installer health. Fabricating epoxy countertops on site creates crystalline silica dust. OSHA identifies this dust as a cause of silicosis, a serious lung disease. Phenolic fabrication does not create this hazard, making it safer for on-site work. Let's lay out the final decision. Epoxy remains the champion for extreme heat and flame resistance, the traditional choice for the most thermally demanding jobs. But for most lab applications, phenolic resin presents a stronger case. It's tougher against impacts and offers distinct chemical resistance advantages. Add its benefits in lead time, installation ease, worker safety, and superior long-term value, and phenolic stands out as a smarter, modern choice. The industry standard is changing. Don't default to the old way. Evaluate the data, consider total ownership cost, and specify the best material for your lab's future.